Greetings to everyone. In this video, we'll be looking at the type of bridges, calculations, civil terms, column failure, the hooks, land, etc. Here we have types of slabs. The first one is fully supported ground slab. The second one is the cantilevered slab, which has both compression force and tensile force. Then the third one is the span slab. Okay, when it comes to survey, we have different types of surveyors. We have a geodetic survey, a marine survey, a land survey, the one that most of us know is the land survey. And we also have a astronomical survey and a cadastral surveyor. In the mixing of concrete, we have hand mixing, and we also have machine mixing. The machine is the one that mixes the concrete. Slurry of cement is a mixed liquid that is composed of cement, water, and various chemicals, additives, and has a certain density. Then a bridge is a structure built to span a physical obstacle without blocking a way underneath. That is a bridge. So when it comes to types of bridge, we have a beam bridge, arc bridge. The arc bridge has four types. It has a hinged less arc bridge, two hinged arc bridge, three hinged arc bridge, tied arc bridge. Then the third bridge, cantilevered bridge. The fourth one, cable stayed bridge. And then we have a suspension bridge. And then we have a bridge abutment, which is a substructure that supports one terminus of the superstructure of a bridge. Here we have a capping beam. Capping beams for piles aims at transferring loads from closely spaced columns or walls into a row for piles, as you can see here. Then we have a bridge deck. The bridge deck is normally found in a cable stayed bridge, the portion that carries all the traffic. Okay guys, right now I want us to look some few calculations. Here we have hook's length. So if you want to calculate your hook's length, you have to say length plus 2 times 90. 90 is for one side. It's for one side of the bar. The one side of the bar, and then D is for the diameter. D is for a diameter of bar. Right, so 90 is for one side of the bar, then D is for a diameter of the bar. So the reason we multiply this 90 by 2 is because we want the total length. The total length for stirrup. The total length of the bar for stirrup actually. Total length, we want the total length for stirrup. That's why we see length plus 2 times 90. So it's length plus 18 diameter. Then as you can see here, for a bend length, the bend length is equal to 16 diameter. Or you can say 16D for a bend length. Then when it comes to the unit weight of a steel, the weight of a steel, if you want to calculate the weight of a steel, you will say weight is equal to diameter squared times length over 162. Guys, here on the weight of a steel. So let me say the diameter, we'll use this one, the one here, 16D. So I will say 16 squared times, let me say the length is about 21 divided by 162. Then here we get 33 kg. The units, if you are calculating the unit weight of a steel, it must be in kg. It's 33 kg. Yeah. Okay. Let's move on to the maximum bending moment at the center of a lintel. So I will show you on how to calculate the bending moment at the center of the lintel. So we'll see it's M is equal to M1 plus M2. So here's this thing. So this is the M that you are looking for. So it's M1 here, and then on the other side we have M2. So we'll say M1 plus M2, then we get the maximum bending moment at the center of the lintel. So for M1 we say M1 is equal to weight times the length divided by 6 plus, for the second moment we will say W, which is weight, times length squared divided by 8. That is the formula for calculating the bending moment at the center of the lintel. Right. Okay guys, let us move on to effective depth of a lintel. The effective depth of the lintel is equal to, its depth is equal to moment divided by Q times a P. This is the formula for calculating a depth. Later on I will show you all the workings on how to do these calculations. Right now I'm still trying to show you the formulas. Okay. We also have area of a steel. So the area of a steel is equal to moment. This moment here is the moment that we calculated. We will use the bending moment at the center of the landing. You will use that moment. So here, area of steel is equal to moment divided by a temperature times a diameter. Remember, the only thing that changes the area of a steel is the temperature. On the hot days, the area of a steel changes compared to cold days. So that's why formula includes the temperature. So the area of steel is equal to moment divided by temperature times the diameter. Right. Right. Okay. So when it comes to a shear force is equal to weight divided by 2 plus a weight times length divided by 2. The formula for a shear force. So these are the calculations. So this one is for a depth of a lentil. Guys, there are two types of column failures. There is a compression failure and a buckling failure in columns. So the first one, when it comes to compression failure, it's when the column are actually loaded the concrete and still will experience some stresses. And the buckling failure, it occurs in long columns.